Indra has asked, raw and business data vault can have historic data, but data retrieval rules performance is a crucial part. Is there any idea to reduce the data read to archive real-time data analytics?
Mm-hmm.
Oh, sorry, to achieve real-time data analytics. So, Nols, do you want to
Sure.
pick that one?
So the beauty of having both the raw data and the derived data as physical artifacts really available means you are already optimized to use the fastest database operation out there, reads. Now, the question here is saying, so what if we want to do reads and do them more frequently or to the point where it's real-time analytics? And so the secret sauce there is, of course, if your derived data cannot arrive at a real-time stream basis, then your performance may obviously have to wait for the necessary dependencies for the derived data to be available. But let's assume that both raw and derived data is readily at hand. If you want to have direct, minimal, equijoin type performance, then introducing a point-in-time bridge table that, based on events or triggers, are appropriately made available or tuned or tweaked, then in the very next time you read or consume your virtual information mart based on top of your point-in-time and bridge table will give you that instant access and minimize the number of reads in the direct access and optimizing whichever retrieval mechanisms your platform may or may not support. And so from that perspective, again, we mentioned in our previous masterclass session that point-in-time bridge tables are an important part of the tuning for performance characteristics at the consumption layer, but that is essentially the way that you minimize the number of reads and sweeps across the data and so on. Now, your mileage may vary depending on the tech you have available. So I'm just putting that caveat out there because some tech just don't allow equijoin or direct access, and your mileage may vary.
Michael, any thoughts to add there?
No, fully agreed. The only thing I would give it a different perspective. Think about this. We want to distinguish here between two different aspects here. One is the data ingestion. I fully agree with Nols. I agree on both sides here with Nols. But the data ingestion is really about getting the data, the messages from the message queue into the raw data vault. And it really depends on your database technology. Can the system, the infrastructure absorb all these messages in a proper time? So it depends on your database, on your infrastructure, on how you scale it up and so on. What I would do is when we capture these messages, a lot of people try to model a real-time feed, let's say with customer records or something, as customer hub and customer satellites, and apply delta checks and so on. What we typically do is we capture real-time feeds as what they are, events. And typically we use a non-hysterized link to capture the messages first. And then once I have captured these messages in a raw data vault, I then start the second phase, information delivery. And that's where I also agree with Nols, where we introduce a pit table. And the pit table is cool in this regard because the pit table is like a custom built index that identifies those records which are relevant for your information delivery. And that's really a subset of the records from your incoming data feed, while the bridge table aggregates the data essentially to the target granularity. So that also reduces the amount of data or amount of information, amount of records being essentially pushed into the dashboarding tool. And then the second part is, right, for the dashboard, think about this. In strategic dashboards where we report over years, we look at data over years. But in real time, we often only look at 240 seconds of the past essentially, and that's a super small pit table where we look at 240 partitions of snapshots essentially, and that's it. So relatively small. And now you could argue, well, the pit table, because we're loading, let's say we have 10 million customers in the hub, you would load 10 million records into the pit table partition every second, every second. Or maybe 100 million customers every second into the pit table partition. So the argument is, well, it's way too slow. On the relation database, I agree. But here's the thing. When we train the pit table concept, we show it on a relational database often. But nobody says that anything that we show on these trainings, on the bootcamp training, must be on a relational database. So what about the pit table, for example? Could be in memory database, for example, like Redis cache. I mean, you could do this in a Java array or a Python array or something. I wouldn't do it, right, because of scalability issues. But Redis cache, for example, scales like crazy, and that's essentially a NDP database, massively parallel cluster database. Has some transaction safety. It's good enough for us, and that's where we can also build a PRT table in memory. And then the cool thing is, while we deal with partitions on a relational database for performance reasons, to always insert full partitions and drop them, in memory, you can just rename the snapshot timestamp and then like shifting the last snapshot partition from the pit to the next second by just updating one field. And then what you do is when a new message comes in, typically you would recreate it or build the partitions afterwards, but here in memory, you just update the cell that's affected, the customer hash key essentially, where there was a change in the settler. You just update that reference to the delta. That's it, super fast. And that's how we built the pit tables and use that then to retrieve the right records from the relational database, from a data lake, what else?
So is there still a place then for like a Lambda architecture or edge analytics, when you're trying to do real-time analytics, it seems like there's lots of architectures that support doing that on the edge, straight through for that need and maybe into the warehouse for a summarized view. Would you do that, or would you leverage the pit table in memory?
Right. So what I would do is I would essentially have my enterprise database. That's the massive data store that collects all the data, batch data, but also real-time data. Which means I wouldn't separate the different data sets just because they're real-time or batch doesn't matter for me. So we just absorb this into one system. The one enterprise database might be a distributed system where you have, let's say, like the pit tables in memory and Redis cache, the rest of the data in the relation database, and so on. Right? Could mix and match of different technologies. Yep. So on high volume of data, you might even consider using a different database mechanism for capturing these real-time messages. But then use the pit tables to identify the records to be sent out.
Excellent. I mean, what an interesting area. Obviously, there's lots of organizations that are dealing with real time, and then there's lots of near real time as well, which is probably dealt with slightly differently to true real time as well. Where it might be operating in an automated production line or something like that. So very interesting. Thanks to Hendra for that question. We'll move on unless you had any other comments, Nols. We'll jump on to Ralph's question.
Just put my architect hat back on.
Okay.
You need to use your architectures for whatever is the appropriate use. So if you have operational needs that are truly operational, extremely focused on a particular element, for the high availability, the cost, the everything else associated to it, it may in fact be more prudent to actually have an operational feature in your ESB, your enterprise service bus, or something similar that actually gives you that capability, and let the long history, the analytics, the large corporate memory be in the vault. It still goes to goes to the vault. It still is in memory. You still have those things, but there's practicalities and also budgetary constraints to real-time processing. It's expensive. And so bear that in mind. Can the vault do it? Absolutely. Has it been done? Absolutely. Question is it the best spend of your money as to which type of delivery architecture you are pursuing here? So just a little bit of we do appreciate and we do like Data Vault, but it doesn't mean the rest of the architecture principles are negated. So we need to make sure that our delivery is appropriate, or our architectural choices are appropriate to the use case. It has to have value to the business.
Yeah. Can we talk about ADI patterns here, or I've seen some crazy approaches where essentially usually you have to have real-time data feeds coming in, right? So we can't get real-time data out of batches, essentially, right? So there must be some real-time feeds coming to the database so we can have a real-time dashboard, essentially. We can only report as fast as the data arrives. That's the idea. And with some cases where I remember one project where the firm that was implementing the data vault essentially was implementing a very sophisticated actual real-time system, but there was no need from a user base, from a user standpoint, to have that actually. So that was complete overkill essentially for the requirements. Nobody needed the data, the reports in real time, but they built this essentially. So that's really overkill. Yeah, fully agree.
Absolutely. I mean, you don't want to be notified the very second someone changes their address. It's unlikely to be super important at that level. So yeah,
well, unless you have a hailstorm coming in, right?
Yep.